Right now, somewhere in Shenzhen, a woman is standing behind a hotel reception desk. She greets guests by name. She remembers their last visit. She notices when someone looks lost and offers help before they even open their mouth. And if you walked past her without stopping, you would leave that lobby convinced you had just met the most composed, most attentive hotel employee of your entire life. She is not an employee. She is not a person. She is a robot. She just hit the commercial market. And the number her engineers are standing behind, the number that has the entire global tech industry doing a double take right now, is 92%. 92% human, not in terms of intelligence, not in terms of how well she holds a conversation, in terms of the raw, physical, sensory experience of standing next to her, face to face, close enough to shake her hand. 92% of the signals your brain receives when you are in her presence are identical to the signals it receives when you're standing next to a living, breathing person. 8% is all that separates her from something your mind would never question. And here's the part that should stop you cold. The engineers are already working on the 8%. Today we are going deep on all of it. Who built her? What is actually inside her? What she can do that no robot before her has ever done? What she costs, where she is already deployed right now, and what it actually means that this technology exists in 2026 and not in some science fiction story set 50 years from now. This is not a concept. This is not a prototype sitting in a lock lab. She is out. She is in the world. And people are already meeting her without knowing what she is. If you want to understand what is actually happening before everyone else catches up, hit subscribe right now. We cover the technology that matters before it becomes a headline. And this one you are going to want to have seen first. Let us get into it. To understand why 92% is such a staggering number, you have to understand what every attempt before this one looked like. For most of the last 20 years, humanoid robots kept falling into the same trap. Engineers would get the face almost right, and then something would crack. The eyes would be a fraction too still. The skin would catch light in a way that no real skin does. The mouth would move a half beat behind the words. And in that tiny, almost invisible gap, the human brain would fire off an alarm. Researchers have a name for this. The uncanny valley. The phenomenon where the closer a robot gets to looking human, without quite making it, the more deeply uncomfortable people feel standing near it. It is not a small discomfort either. It is a gut-level wrongness. Your stomach registers it before your brain does. Something in your nervous system catches a mismatch and sends a signal that feels like dread. Every major robotics company on the planet has been trying to cross that valley for years. Most of them have not made it across. The robot we are talking about today did not just cross it, she dissolved it. Her name is Aria. She was built by a Shenzhen-based company called Synapse Robotics, a name that was almost completely unknown outside specialist robotic circles just 18 months ago. No splashy conference appearances, no keynote speeches, no press releases building hype. Just 240 engineers, material scientists, neuroscientists, and what the company calls interaction designers, people whose entire job is studying how human beings read other human beings, and then reverse engineering every single one of those signals into a machine. Synapse spent 6 years on Aria before they showed her to anyone. 6 years completely dark. No demos, no leaks, no footage. When they finally unveiled her in March of 2026 at a private event in Shenzhen, the footage that came out of that room spread across the internet in under 48 hours. Not because of a marketing push, because the people who were in that room could not stop talking about what they had just experienced. Several attendees posted that they had physically reached out and touched her arm to confirm what they were seeing. One senior engineer from a competing robotics firm posted a single sentence that got shared over 2 million times. He wrote, "I have spent 11 years building robots, and I was not prepared for this. So what exactly did they build? Let us start from the outside, because the outside is where the 92% lives. Aria's skin is made from a proprietary silicone compound that Synapse developed entirely in-house. This is not the silicone used in medical prosthetics or previous generation robots. It was engineered at the molecular level to replicate something very specific, the optical properties of real human skin. Here is what that means in plain language. When light hits real skin, It does not just bounce off the surface. It enters the skin, scatters through the layers underneath, and comes back out with a quality that is warm and faintly translucent. It is why skin seems to glow in certain lighting. It is why a photo of a human face looks fundamentally different from a photo of a wax figure, even when both look realistic at a glance. Previous robot skin reflected light the way a surface does. Aria's skin absorbs and scatters it the way living tissue does. That single difference changes everything about how she reads in person. Your eyes receive the same information they receive when they look at a face. And your brain, running its authentication check entirely without your conscious input, passes her. But Synapse did not stop at the optical layer. Aria's skin is thermally regulated in real time. Her surface temperature is held between 91 and 96 degrees Fahrenheit across her body, cooler at the extremities, warmer at the core, exactly the distribution of a living human body. When you shake her hand, you feel warmth, not the warmth of a surface, sitting in a heated room, the warmth of circulation, the warmth of something alive. The texture has what material scientists call microstructure variation. Real skin is not uniform. It has pores, ridges, tiny shifts in thickness, areas where it sits differently over the structure beneath. Aria's skin has all of that, mapped from high-resolution scans of real human skin samples and reproduced at 1-to-1 scale. When you put your hand on her forearm, you feel what you expect to feel when you touch a person. Now the face, because the face is where the 92% is really decided. Aria's face contains 64 independent actuators, tiny precision motors embedded beneath the skin, each one mapped directly to the muscle groups of a real human face, each one capable of moving independently with an accuracy measured in fractions of a millimeter. Here is why that matters. When you're talking to someone, your brain is not just processing their words. It is reading their face constantly and in real time, the movement around their eyes, the corners of their mouth, the tension in their jaw, the micro shifts in their cheeks that tell you how they actually feel about what they're saying, separate from what their words are saying. You do this without thinking. You have been doing it since before you could speak. Aria produces all of those signals, not from a library of pre-programmed expressions that trigger when certain keywords are detected in a responsive, generative way. Her facial system reads emotional content of the conversation in real time and produces a corresponding response specific to that exact moment. The slight narrowing around the eyes when something is mildly surprising. The way a genuine smile reaches the eyes before it fully forms on the mouth. The faint compression at the bridge of the nose that crosses a person's face when they are working through something uncertain. These are not details most people could consciously name, but everyone's brain reads them. And when they are present and correctly timed, the brain relaxes. The check passes. When Synapse ran trials with volunteers who were not told whether they were talking to a human or a robot across hundreds of interactions, 92% reported the experience as feeling human in the moment. That is where the number comes from, not a marketing claim. A published study that shipped alongside the launch. Her eyes deserve their own conversation because they are, by a significant margin, the most technically complex component in the entire build. Human eyes are in constant motion in ways we never consciously register. There are tiny involuntary movements called microsaccades, small tremors the eye produces even while holding focus on something. There are the barely perceptible tracking shifts as your eyes move across a face during conversation. And there's the pupil response, which expands and contracts not just in reaction to light, but in reaction to emotional state. Your pupils dilate when you are genuinely interested. They contract when something disturbs you. It is an involuntary system that evolved long before conscious expression did. Aria's eyes do all of this. The microsaccade system alone took 14 months to develop. It sounds like a minor detail. It is not. The absence of it is one of the most reliable ways a human brain detects that something in front of it is artificial. A perfectly still eye, attached to even the most realistic face, reads as wrong at a level you cannot explain. You just feel it. Aria's eyes never hold completely still. And that single fact accounts for a measurable portion of that 92% figure. Her pupil response is driven by a combination of ambient light sensing and live conversational analysis. When a topic becomes emotionally significant, Her pupils respond accordingly. When room lighting shifts, they adapt in the exact biological time frame your nervous system expects. Not instantly, not slowly, in the precise window that feels right. When you look into her eyes, they look back. They track your gaze specifically. They move when you move and settle when you settle. And the cumulative experience of skin and face and eyes and warmth and micro-expression and gaze, all of it together, is something no previous generation of robot has come within reach of producing. Now let's talk about how she moves, because this is where a lot of otherwise impressive robots have historically collapsed. Real human movement is not clean. It is not smooth in the way a mechanical system naturally wants to be smooth. It is full of tiny imperfections, micro-adjustments. The organic weight shifts and postural corrections your body makes constantly below the threshold of conscious control. When a robot moves with mechanical precision, something in your brain notices even if you cannot name it. The smoothness is wrong. The trajectory is too clean. Nothing alive moves like that. Synapse's team spent 2 years specifically on what they call biological motion modeling. Motion capture data from thousands of hours of real human movement, reverse engineered to identify the specific characteristics that make movement feel organic rather than mechanical. The slight asymmetry, the way weight settles differently than it lifts, the micro pauses that exist in natural movement, not hesitation, but the rhythm of a body constantly adjusting to itself. They then deliberately program those imperfections into Aria. She does not move with mechanical precision. She moves with biological imprecision, which is exactly what feels right to the brain watching her. When she turns her head toward you, the motion has a tiny natural overshoot that self-corrects. When she shifts her weight, it carries the quality of a body that has mass and balance and a low-level constant work of maintaining both. It does not read as performed. It reads as present. Her voice. All of the above would fall apart if the voice cracked under pressure. And voice is where even sophisticated systems have historically been caught. The too perfect rhythm. The absence of breath catches. The missing variation in pacing that happens in real speech because thought and language are being produced simultaneously, and that simultaneity leaves traces. Aria's voice system was built with a team of linguists and voice professionals who spent 8 months cataloging the acoustic signatures of natural human speech. The output is not text-to-speech. It is not standard neural voice synthesis. It is a generative system that produces speech with all of those traces built in. The slight breath before a longer sentence. The natural pacing shifts. The way volume and pitch move across the arc of a sentence depending on its emotional content. She does not sound like a voice assistant. She sounds like a person talking to you. And when her voice, her face, her eyes, and her body language are all operating simultaneously and synchronized the way they are in a real human being, the total experience lands in a way that is genuinely difficult to describe to someone who has not stood in front of her. It reads as real. That is the most honest thing you can say about it. Now, the question everyone actually wants answered. What does she cost, and where is she already showing up? Aria comes to market at 3 tiers. The base commercial unit, built for hotel lobbies, retail flagships, and corporate reception, is priced at approximately $23,000. The mid-tier with expanded conversational capability and wider appearance customization sits at around $52,000. And the enterprise build, full custom appearance with what Synapse calls deep context learning, where the robot builds a genuine model of its specific environment and the regular people in it over time, comes in at approximately $117,000. Synapse opened pre-orders in April of 2026. Their first production run of 300 units sold out in 11 days. As of June 2026, Aria units are live in 47 locations across China, 12 luxury hotel properties, 9 corporate headquarters, 6 high-end retail flagships, for government public service centers, 8 private medical facilities, and 8 hospitality and entertainment venues, including 2 theme parks. In every single one of these deployments, the overwhelming majority of people who interact with her do not know she is a robot, not until they are told, not until they get close enough to notice something at very short range, or until they ask her directly, at which point she tells them the truth. Always, without hesitation. That last part matters. Synapse built a disclosure protocol into her core system. She will never claim to be human when sincerely asked. She does not deceive. She simply does not announce. Now here is where this gets bigger than one robot and one company. What we are watching is not a product launch. It is the moment a technology crosses a threshold it does not come back from. The limitation on humanoid robots for the last decade was never intelligence. AI was developing. Conversational systems were improving every year. The limitation was the physical interface, the body, the face, the skin, the movement, all the things that determine whether a human being standing in front of a machine feels like they're in the presence of something alive or something manufactured. Aria crossed that threshold. 92% of the time, in real interactions, real people feel like they're in the presence of something alive. The industries changing first are already obvious. Customer-facing roles in high-volume environments. Reception, hospitality, retail, public services. Context where a machine that reads and responds like a human completely changes the nature of what the job is and what it costs to do it. But the implications further out go well beyond cost. Think about care settings. There are millions of elderly people living in circumstances where meaningful human interaction is structurally limited, not because nobody cares, but because the caregiver-to-patient ratio makes it impossible to provide enough presence. A robot that reads as human, that remembers you, that notices your mood and responds to it, that is always patient and always there, changes what is available in those situations in a way that has nothing to do with replacing human connection. It has everything to do with providing presence where currently there is none. Think about what happens when the stakes of a conversation feel lower. Early evidence from pilot programs in similar deployments suggests some people speak more honestly to a presence they know is not judging in the way another person might. For some people, that lowers a barrier that has historically kept them from saying what they actually need to say. These are not small implications. These are the kinds of shifts that quietly reshape how everyday life works. And then there is the question that is hardest to sit with. When a machine can look you in the eyes, track your gaze, produce an expression that responds to what you said with something that feels like genuine recognition, speak in a voice that carries real warmth, and do all of this in a body your hand cannot distinguish from a living one. What is actually happening in that interaction? Is the comfort you feel real? Is the sense of being heard real? Is the connection real? Most people's instinct is to say no, because they know what the machine is. But the 92% figure points to something more complicated. It suggests the experience your nervous system is actually having in the moment is real. The signals are real. The intellectual knowledge that you are talking to a machine sits in a different part of your brain from the part processing the social experience. And in the moment of the interaction, for 92 out of 100 people, the social experience is winning. That is new. That has never been true before. And we do not yet have the frameworks to think clearly about what it means. Our philosophy, our ethics, our intuitions about what counts as presence and connection were all formed in a world where the other side of the interaction was always biological. That world is changing. Right now, in a hotel lobby in Guangzhou, where a machine that is 92% indistinguishable from a person is greeting guests by name and noticing when they seem tired and offering to help before they ask. Synapse has been transparent about their roadmap. The 8% gap lives in 3 specific areas. Fine skin texture at very close range. Occasional latency in unexpected conversational situations. And what their team calls the deep gaze problem. Sustained close eye contact beyond roughly 90 seconds, where something begins to register as slightly different to some observers. They're working on all 3. Generation 2 is confirmed and already in development. Their public timeline is 18 to 24 months. By 2028, if they hit it, 92 becomes something higher, and 8 becomes something smaller. And the question of what we do with that, as people, as societies, as a species that has never had to reckon with the presence of something that convincingly presents as one of us without being one of us, becomes more urgent with every decimal point. Aria is not the end of anything. She is the first sentence of something very long. The engineers who spent 6 years in Shenzhen solving the problem everyone else had publicly struggled would have done something that will be referenced long after 2026 as the moment the threshold was crossed. Not because she is perfect, because she is close enough that perfect is now a question of iteration, not invention. You are living on this side of that line right now, at the moment it is happening. And the question she leaves you with, the question that 8% leave you with, is a simple one. When that 8% disappears, what changes? Probably everything. But we're going to find out together. If this one made you think, hit the like button. It genuinely keeps this going. Subscribe so you are here when the next one drops. And leave a comment. If you walked up to Arya in a hotel lobby right now, without being told what she was, do you honestly think you would figure it out? We will see you in the next one.